Hi folks, and welcome back to Math with Captain Ron. I'm making this video here to provide a couple examples of solving equations involving the sine function. We're going to take a look at these two examples, and we're going to look for solutions only between 0 and 180 degrees, because those are the relevant ones for solving triangle problems. So for this equation, sine theta equals 0.3. This is solved by taking the inverse sine of both sides. So theta is going to be the inverse sine of 0.3. Would somebody give me a numerical value in degrees, please? 17. All right, so theta equals 17 degrees should solve this. Now what you have to get used to thinking about is when you're solving these trig equations like this, sines and cosines, they're always going to have a pair of solutions. If I draw a quick picture for this problem, what we have found is the first quadrant angle of 17 degrees has a sine equal to 0.3. However, if I reflect this about the y-axis such that that's 17 degrees, we have another angle right here that has the same sine. See how these have the same y-coordinate. And that second angle, I'll call it theta 2, is going to be 180 minus 17, or 163 degrees. Both of these angles, both 17 and 163, should have a sine equal to 0.3.
Yeah, they do.
Okay. Let's try this one. So this can be solved by taking the inverse sine of both sides. So we're going to have theta is the inverse sine of 0.8. Can somebody give me a numerical value? 53. Now again, your calculator always gives you a first quadrant solution to this, and that has to do with the domain of the inverse sine function, which we'll talk about later. For now, it's enough to know that you'll always get a first quadrant solution out of these things if this number is positive. Your second solution you get from a quick picture. 53 degrees in quadrant 1 looks roughly like this. However, if I create another triangle over here that's symmetric with this one, such that that's 53 degrees, we have a second angle right there, theta 2, that has the same sine. The important thing is, why do they have the same sine? Same y, whoops, same y, same r. And that second one is going to be 180 minus 53. What's that one? 127? 127 degrees, both of which will solve this equation here, presumably. Somebody check and make sure that the sine of 127 degrees is in fact 0.8, plus or minus a little rounding. Okay, we're good. So it's just meant to be some examples of solving a simple sine function and showing both the first and second quadrant solutions. This will be relevant for our discussion on law of sines, which is upcoming. Hope that this has demonstrated that for you. Have a great day.